Hello, everyone. Nice to be back. Hello, Dr. Nasser. Great to see you. Yes, it's good to be back. And yes, hi, Dr. Divya. Yes, we are also very eager for today's session. It is so good to be back after a rather long break while I was recovering from COVID. Well, I'm fine now and all good to go. So we are back, and today we have a session on our research on technology, which is on research and health sciences, the first part, which is all about analytical studies, things like sample size. So, if this is something you are interested in, you should hang on and watch the rest of the session.
Hare Krishna. Good morning to all, and I'm happy to be a part of Oral Pathology 360. And I thank Dr. Mandana for giving me an opportunity to be with you all today. Today, I will be discussing certain concepts in research which come under the umbrella of must-know concepts, and this would facilitate in extrapolating our results to the population. That means your research is successful if you can understand these concepts and implement them. So all of us know that research is a systematic process done very scientifically, which not only is done for generating new knowledge, but could also help in solve a problem or improve some existing issues. So to understand research, there are two components. One is called the anatomy, where we frame the research question. We try to design the study, like which design we would like to choose. And we have to select the subjects from a population. Since we cannot study the entire population, we need to draw a sample from this population by an appropriate sample size estimation. And the physiology of research is that we need to study certain variables. That is your field of interest. What is that you want to measure? So using these measurements in a sample, you subject them to some statistical tests and you draw inferences about that specific phenomenon in a population. So this is the overview of the entire research process. So as I told you, we have a population. You cannot study the entire population. It is just not possible. So you need to draw a representative sample from the population by a sampling method. And then you will conduct your research on this sample selected. So what is the ultimate aim of this sample size estimation. It helps you in a statistical inference. That is, it's a process of inferring features of the population from observations in a sample. So it is simple. You have a population, you draw a sample, you conduct your research on this representative sample, you find out what your results are, and then apply them back to the population. So I'll just take you through a small journey through these concepts surrounding the sample size estimation, which are very important. Now, one small word before I go ahead is you need this sample size estimation when you're doing an analytic study. So what is an analytic study? As we all know, when we start research or when we talk of looking at a particular topic, we need to frame the research question. This is the most important and difficult aspect of research. So you need to focus on your interest, then develop a research question on that interest. And if your research question has words like more than, less than, or in contrast to, or association between, or cause of, compared with. Now let me give you an example. Now you may have one drug more efficient than the other drug, and you want to compare both these drugs. So here you're doing an analytic study. So this is where you need to estimate the sample size and all the concepts necessary for your research to become acceptable are incorporated in this. So let us go through this journey. I want to just explain to you what variables are before we actually get into the other factors. And then we have the concepts of sample size, namely hypothesis, alpha, beta, power, and effect size. And I'll try to explain to you this with examples. Now, please remember the title of this article, Probiotics Reduce the Prevalence of Oral Candida in the Elderly Patients, a Randomized Control Trial. So this study got published in Journal of Dental Research, which is a very prestigious journal, very carefully executed. And then with this specific title, I can explain so many things and the concepts from this article itself. So throughout my presentation, I will be using this title and will be referring to it to explain the concepts. So please remember this title, Probiotics Reduce the Prevalence of Oral Candida in the Elderly. It is a study that was done in the United Kingdom and where the government funds the medical expenses, and prophylactically they wanted to reduce the incidence of oral candida in the elderly population. So they had the gold standard design, a randomized control trial. I'm emphasizing on this to make you understand the importance of even your design. So let us see what variables are there in a study. Now, so what is a variable? It's a characteristics that vary from one study subject to another. So when you are designing your study, you should make sure what is a variable that we are going to measure. This should be very clear. So now let us look at these. These are examples of some variables: blood cholesterol level, salivary glucose level, mouth opening, colony forming units estimated for candida, gender, blood groups, mild, moderate, severe. Now, each variable has its own important factor here. Let us look into this. Now, when you have a variable which can be quantified and for which you can estimate the average, and you can also have a typical ranking or interval ratio, we call it as a continuous variable. For example, you take blood cholesterol level. Now I can take in a classroom all the students. I can estimate individually the blood cholesterol level. Then I can compute an average cholesterol level. I can also give an interval ratio ranking. Say I can say from 50 to 100, 100 to 150, 150 to 200. So these type of variables are referred to as continuous variables. Then we have the other type of variables which are called as the categorical variables. Now categorical variables may be three types: dichotomous, nominal and ordinal. Example of a dichotomous variable is gender. So when you are trying to understand the hemoglobin hemoglobin estimation between male and female, then you're having a dichotomous variable. They are there, but there's no order and there are only two variables. Then when we have the nominal variables, for example, the blood groups A, B and O, there are three different groups. There is no order, but they all come under one umbrella. If we have ordinal variables, we have mild, moderate, severe. For example, pain. I need to describe pain. I may ask the patient, are you having a mild pain? Or I can elicit whether the patient is having a mild pain or a moderate pain or a severe pain. Or being an oral pathologist, I can talk of dysplasia. I can say mild, moderate, severe. So when I'm addressing these type of variables, they are called as the ordinal variables. So to summarize here, variables are of two types: continuous variables or categorical variables. So when we are doing our research, we must understand what are the variables we are going to measure. One more concept with variables, we have something called as the predictor variable and one is called as the outcome variable. So association between two variables, one that precedes is one is called as the predictor and the other is called as the outcome variable. Now, in my example, I was talking to you about probiotics reduce the prevalence of oral candida in the elderly patients. The variables there are, you have probiotic, that is one variable. It is dichotomous. And we have the outcome variable, that is the colony forming unit, that is the candida. Now, let me explain to you about the study in little more detail. So how did they conduct this study? By random selection, they recruited patients into two groups. One group was given cheese with probiotics and the other group was given cheese without probiotics. It was a double-blinded study, and then they went on carrying out the further aspect of the research. So here the predictor variable was the probiotic, and then the outcome variable were the colony forming units of the candida. So summarizing the variables before I move on to the goal of the sample size calculation, we had, let me just go back to that slide. We had continuous variables, categorical variable. Continuous variable, here we are having is the colony forming unit and it was the outcome variable. Categorical variable we had yes probiotic, no probiotic, and probiotic was given to estimate the outcome, that is the colony forming unit. So now let us understand what is the goal of the sample size calculation and why should we do it. So it gives you an appropriate number of subjects you have to recruit into the study. It also tells you whether the given study design is practical or not. Study design, I'm not getting into details, but for the design you have chosen, if the sample size is very large, initially itself you have an option to change the study design to make the sample size optimal. And remember, it is a mathematical estimate that should be done. But don't get worried at this point of time. If we tell the statistician what we want, then they will take care of the math part of it. And also the sample size takes into account that errors are not committed in the conduct of the study. This you will understand as I move further. So we want an ideal sample. We don't want a large sample because it is not cost effective, consumes a lot of time and also manpower. If you have a small sample, you're unable to detect clinically important results. So you want a sample that is not very small and also not very large. Now, what are the statistical issues around that? Let us see. Now remember my title, Probiotics Reduce the Prevalence of Oral Candida in the Elderly Patients, a randomized controlled trial. That study concluded that probiotic intervention reduce the risk of high yeast counts by 75%. Thus, probiotic bacteria can be effective in controlling oral candida in the elderly. Yes, this is a study published in JDR, very prestigious journal, and we are going to accept this. But whenever we are looking into a conclusion, we should be very careful in trying to ask two questions. Did the study really find what they wanted to find? And how do I believe that their result is correct? So these two things should strike your mind. That also is revolving around the sample size estimation. Now, we know that a sample represents a larger population. It makes inferences about the population at the expense of being wrong. So, however stringently we do our study, there is a scope that we might find something that is not real, or we may miss something that is real. So when we are looking for something in a sample, will you be able to find something that is really there? That means your study should have adequate power to detect the difference you want to see between the two groups who are included in your study. Convince others what you found is real. That is called as alpha. So how do you approach, or should I say, convince others that my results are correct? For this, I need to explain to you what a hypothesis in brief and what is alpha, or the type 1 error which I just mentioned. And then we have the beta, the type 2 error. We have the power, which is 1 minus beta. And then we have the effect size with the variance incorporated too. Now in this presentation, which I'm calling it as part 1, I will be talking to you about the hypothesis and alpha. And in my part 2 presentation, I will be covering about the beta, the power, and the effect size. So what is a research hypothesis? It summarizes the elements of the study, the sample, the design, the predictor, and the outcome variables. So in my example, the research question would be, do probiotics reduce the prevalence of oral candida in the elderly patients? So it tells you the sample, elderly. It tells you the design, randomized control trial, the predictor, probiotic, and the outcome, or the colony forming unit. So when do you need to state a hypothesis? You need to state it for those studies that will use tests of statistical significance to compare findings among groups. So you have your variables, you measure your variables, and then you subject your variables to a statistical test. Now, when we have a hypothesis, there are two types, null and alternative. I'll be focusing much on the null hypothesis. So when we say null hypothesis, there's nothing going on. So in my example, null hypothesis would be probiotics do not reduce the prevalence of oral candida in the elderly patients. So why do we need a hypothesis? Remember, when you do your research, you measure your variables and you're doing a statistical test, you actually get a number. And that number means nothing unless you have a hypothesis. I'll be explaining to you this in a few slides from now. So let us see this now. A long time ago, statisticians figured out that the probability that a sample of a given size would find something, even if there was nothing is going on in the population. So the null hypothesis is true, but still we may find something that is there. So after a study, we can determine the likelihood that whatever we found in our sample could have occurred by chance. Even if nothing was going on in the population, that is, even if null hypothesis was true. That means the study has an inherent error which is called as the type 1 error, or it is called as the alpha. The preset maximum chance of finding something if it really isn't there. So I'm doing the study, I'm conducting the study, I expect good results, but there is a chance I can go wrong. I'm telling myself, even if I go wrong, the chance of going wrong in that study is only 5%. And I'm calling it as alpha. And that process of going wrong is called as the type 1 error. And this type 1 error is usually set at 5%. That's why alpha is 0.05, which we call as the level of statistical significance. Whenever you want to have the least type 1 error, then you should have a low alpha. Now, let me go ahead with this a little more. Now, all of us are familiar with the p-value. Once our research is done, we are excited to know whether the p is less than 0.05 or p is greater than 0.05. So when the data are analyzed by statistical test, such tests determine the p-value. It is the probability of seeing an effect as big or bigger than that in the study by chance if the null hypothesis actually were true. Now let me explain this. So we have done this study. We have measured the variables. We have subjected it to a statistical test, right? Now, what do I achieve after that? I just have a number which is called as the test statistic. Now, this test statistic does not carry any meaning if you do not find out the probability for this test statistic. Now, for example, we have the log and the anti-log tables. So similarly, for a given test statistic, there is a table for each test you have used. Now, you may have a test like a t-test or a chi-square test, etc. So for each test, there is a p-value table. So for your test statistic, you need to go determine the probability value from that table. If the probability value is less than your predetermined chance of 5%, that is the chance you have given yourself to go wrong. So if the p-value is less than the chance, then you reject your null hypothesis and accept the alternative hypothesis. This is what I will be able to explain to you in the next slide. So if we assume that the null hypothesis is true, how likely is it that the observed results could have occurred? If the chance is small, a chance is less than 5%, I have myself given an allowance of that 5% chance. It's okay if my results are wrong by 5%. So if the chance is small, if your probability value is less than your statistical significance of 0.05, then you reject the null hypothesis. So in my example, I reject my null hypothesis that probiotics do not reduce the prevalence of oral candida and say that the probiotics do reduce the prevalence of oral candida. If the chance is not small, if that p-value is greater than 0.05, the chance which I have given myself to say, okay, pass it on, then I have to do not reject the null hypothesis. So you need to accept the null hypothesis and say that probiotics do not reduce the prevalence of oral candida. So if we reject the null, naturally we have to accept its alternative hypothesis, namely that there is something going on in the population. Now, where did we get this 5% from? It is from the normal distribution curve. For biological continuous variables here, you can find that most of the normal values are within the 2 standard deviation, but there are outliers of about 5%. So that is the reason we have the statistical significance, which is accounted as 5%, and that is 0.05. I mean, normal distribution curve is a separate lecture by itself, which will need a lot of details. But this point of time, I'm just trying to justify that 5% here. So let us look into the possible results of a hypothesis test. So what is this? Now we have said we had a hypothesis, and we are doing a hypothesis test, and we are trying to understand what is alpha and little more than beta. So now this is a table you need to concentrate on. It has 3 columns and 3 rows. So the top portion of the column says test in the study sample, that is the results which you have got from your study. The second column says in truth, in reality, in the God created world, that there is an association between the predictor and the outcome, or there is no association between the predictor and the outcome. So the predictor I'm talking to you about is the probiotic. The outcome I'm talking to you about is the colony forming unit. So let me explain it with this example. Now, based upon my study result, I reject the null hypothesis. That means I tell that probiotic do influence candida. So I reject my null hypothesis. And even in the reality, if the truth is that there is an association between the predictor, the probiotic, and the outcome, that is the colony forming unit, then I am right. My research is right. I can extrapolate it into the population. But there is an inherent chance, as I have explained to you, that if there is in reality no association between the predictor and the outcome, that is the probiotic and the candida, but based on my result, I reject the null hypothesis. When in reality the null hypothesis is true, I'm committing a type 1 error, or called as the alpha error. Now this alpha error, to accommodate, to see that your studies do not have this, you establish that 5% statistical significance and incorporate also this alpha in the calculation of a sample size, such that minimal type 1 error is observed in any given study. Now let us come to this situation. Fail to reject the null hypothesis. That is, you're actually accepting the null hypothesis. Now, if the reality in the world is that there is no association between the predictor and the outcome, that is the null hypothesis. That is, the probiotics do not influence the prevalence of the oral candida, then my study results are correct and there's nothing for me to worry about. Now, suppose I fail to reject the null hypothesis, that is, I accept the null hypothesis, and in reality there is an association between the predictor and the outcome, that is, the probiotics do influence the oral candida, but I'm failing to reject the null hypothesis based on my study result, then I'm committing a type 2 error, which is called as beta. So type 2 error is failing to reject the null hypothesis when it is actually true. That is, you accept the null hypothesis. So these are the possible results of an hypothesis test. So having completed this table of possible results of hypothesis test, now let me summarize this part 1 of my presentation today. We started off with what is a research question, and then what is a hypothesis? What kind of studies need a hypothesis? Why do you need a hypothesis? And also the importance of listing down your variables at the beginning of your study and try to understand what is the predictor and the outcome variable, so that you will be in a position to apply the particular statistical test. Let me remind you here, I did not discuss the statistical test because that is not the scope of the presentation today. And then I've introduced the concept of alpha, that is the type 1 error, and explained to it. Then we also did with beta, but it was just an introduction. Now in part 2 of my presentation, I'll be talking to you more about beta, power, and the effect size. And then once you have all these executed, your results can be extrapolated to the population from which you have drawn the sample. So getting right answer to your study is a matter of designing and implementing the study with correct number of subjects, that is the right sample size. I have done half my journey with these concepts in sample size. I'll see you in the next part of my presentation to complete the rest of the factors. So thank you. And I would like to acknowledge my management, Raga's Dental College and Hospital, my mentor, Dr. John Greenspan, and my teachers at California, and all my colleagues and postgraduates at Raga's Dental College. Thank you.
Thank you, Dr. Uma. That was indeed in keeping with my experience of your lectures. Very clear, very succinct, very to the point, and focused. I loved it. Very nice. Thank you.
Thank you, Dr. Mandana.
Yes,
And
right.
before anything, I would like to take this opportunity to thank one of my biostatistician, Mrs. Hema, who's always been a big drive for me in this aspect of the subject. Thank you. I thank her.
Yes. That always makes a great amount of difference when you have a good biostatistician with who you have the rapport where you can discuss and explain and establish the study properly. Yes, makes a lot of difference. So let's see if we have any questions. Everyone, please type in your questions, your comments in the chat. And let me see. Sorry. Okay, there is Dr. Sultan saying, very informative session. Dr. Ramaya saying, excellent explanation, which truly it was. And Dr. Shruti. Sorry. Okay, so we have, yes, Dr. Shruti, who says, you don't fail to teach something new each time. And that's very nice, true. Okay. And we just seem to have a lot of everyone saying that it was very nice, which it was. Well, Dr. Nasser saying very nice, thank you. Dr. Upala, Divya, excellent, ma'am. Thank you so much. Okay, there seem to be no questions as yet. And Dr. Dinkar also saying, thank you, ma'am, for a good explanation on basic research. Yes. So no questions. But I have to say this has been such an important topic because I think it is impossible to do any advanced studies in the health sciences without research. In fact, there are countries where even the basic degree requires research. And yet, so much of it is, I'm sad to say, literally wasted. So much of time, so much of money, and sorry, like I used to tell my postgraduates, this is a time, especially the study which they do as a thesis when they are students, because you almost have an entire department dedicated to helping them finish a specific research, which does not happen after you have finished, but so, and it is so important, and it's so much can be done with that research, and yet so often it goes wrong because of that very fundamental mistakes in the design and the numbers. I think the number of studies we read which at the end say, sadly the sample size was too small and therefore this just means nothing almost. It is, and for conditions which are like ample, where there should have been no problem getting the right numbers if we had just done the calculation right. So this was really very spot on. What is your own thought and the reason you are interested in research and in the biostatistics and the design?
I think it was basically that being in Raga's Dental College, and I had my excellent colleague, Dr. Ranganathan, and then I was working with HIV with Dr. Cynthia Solomon and group and Dr. Kumar Swami, where my first exposure to research began. And then I wanted to make some meaningful contribution at some point of time. And therefore, I pursued my interest in that. And my most important objective would be, to translate to students whatever little I know, so that I think they can carry out a good, meaningful, because they work very hard, so they need something
Yes,
which they can extrapolate. So that would be my main objective of getting deeper into the subject.
true. Very right. Students are finally at the real heart of almost everything we do. Okay. We still don't have questions. We just have everyone saying that the presentation was great. This is one of your students. Yes.
Dr. Shekhar, I
Dr.
think
Sakar. Yeah.
he's in Malaysia now.
Okay. And Dr. Gauri Shankar. Nice presentation, ma'am. Thank you. Okay. So, is there anything else you would like to add since we haven't got any questions and comments? I think it was so clear there is nothing to say. Okay. So, anything you want to add?
Yeah, I would just like to just emphasize that, when you want to do any research, first of all, you should understand what type of research are you doing. First, it begins with qualitative or quantitative. And if you're doing a quantitative research, you must have the subjects, the number of subjects, and how you're going to select the subjects, and the design done in the initial part of your study. Because sometimes I've seen in my experience there are many postgraduates who come back and tell, ma'am, we've done a very expensive study, we've invested so much, and we have not got any significant results. And can we do something about this? So I think there's very little you can do about it at that point of time. So it's okay sometimes if you don't get an adequate sample size when you're doing your dissertation, or you have your own limitations there. So, but that time you can try to do a monograph of a particular question you're trying to answer, or at least you can introduce the concept, and later, you can do a detailed study on that. But you should not get discouraged. But also at the same time, you should remember power is very essential. That's what I'm going to cover in the next part of my presentation. Of course, that begins with your statistical significance. So do it the earliest and consult the biostatistician at an appropriate time. That is the beginning of your study. Because we are not expected to know the mathematics of biostatistics, but the English of biostatistics, I think we should know, so that we can translate the information to the biostatistician who will definitely lead us through the study. Yeah. Thank
That
you.
is so true. So often people approach the biostatistician at the end with
Yeah,
the
we should go
results.
at the beginning. Yeah, if I can convey, I will be very happy. Yes.
True. I'm sure that you have. And I'm sure this will be watched by many and it will be appreciated and remembered. Remembered is the key point. Yes. Okay. So, with that, let me say thank you. And
Thank you, Dr. Vandana, for
you're
giving
most
me this
welcome.
opportunity.
It has been a pleasure. It is always a pleasure working with you and listening to you. And it was so this time too. Thank you so much. Here is your little certificate. I will share it, the PDF, with you later.
Thank you.
You're most welcome. And now some information about the upcoming events. So, of course, first is that we had our anniversary celebration. So now that it was being edited and then I fell sick, so it was for quite some time not available. So now it is again put back in the public postings of the channel. You can watch it. And I have inserted chapters because it is a long event. It's about 2.5 hours, but now you can watch sections of it as you want. Chapters are included, so you can maybe watch a part and then watch the rest, whatever. But it was a very interesting one. I hope you'll enjoy watching it. The link is there in the descriptions. And of course, you can also find it on the channel and also on the website. The other thing is that, of course, the souvenir with all the details, which is all the abstracts of everything that was presented in the conference, in our international conference, is on the website. Again, the link is in the description. You can watch it, you can read it on the website itself, or you can download a PDF. If you just go to this page, once you go to the website, just go to the publications tab and it is right there. And as we mentioned, now next week we are going to have the second part of this lecture, that is must know concepts in research, and Dr. Uma Devi will be completing that presentation. Yes, and with that, we are at the end. Thank you so much for being with us. Thank you. It is always nice being here. I missed you all. I missed the interaction. We are back. We will continue. And I definitely look forward to all of you being here. With that, let me say bye. And I'm not finding my bye bye video. Okay, here it is. Bye, everyone.